Hi, this is Craig with Gertech, and I'm going to walk you through the traffic light simulation on the LogixPro simulator. So this is a pretty standard traffic light. It's 12 seconds for the cycle. So this light, the red light is red for 12 seconds. The on the green and yellow, I believe it was green for 8 seconds and yellow for 3, and then 1 second with both lights red. So that's pretty standard, except for the time of the green. But another requirement was the pedestrian button being pushed while it's red on that side. You want to make sure that it waits until the next time that it turns the light this side turns red. That way the pedestrian has the full cycle time to get across. As you see, it just happened there. So yeah, so that's that. So let's take a look at the logic to see how I accomplish that. So this is my S115 bit. This is the first scan, first pass bit. This bit is only becomes active when the um, controller is first put into run. So it's the first scanning of the logic. It will not become active any other time. So this is a good time, a good way to reset everything, to clear out any latches or set latches, to get everything set exactly how you want to. Um, so that's why that's there. Next, the customer just wanted just one timer. And so what I did is, to keep it simple, is I just built a 1 second base timer, because it's 12 seconds per side, and I just figured 1 second would be the easiest way to handle everything. And then down here, I just count every second. And so what happens is when the counter becomes done, it comes down here, and the one I use a one shot to make sure it only counts this being active once. Sometimes if you don't use a one shot, when your counter will be erratic. So you want to make sure that that only counts these once. So once this counter becomes done, what happens is this becomes not satisfied, which turns this off and resets it, which clears the done bit, which will make this satisfied again, which will turn the timer back on. So it's a self-resetting timer in that way. Um, so okay, there's that, and that's how those two interact. And then down here, I have the side counter. So basically, I just used I think it was it's down here. It looks like 0 is going to be the left side and 1 is going to be the right side. So basically, every time that this one gets done counting to 12, it will again one shot over to this counter, and um, and then it'll count up. And when this also happens, we go ahead and reset this guy so it can count to 12 again. Then what happens next is then when this counts to 2, which would be technically the third time, right? Because we start with 0. So when this becomes 3, so basically what happens is this does 2 cycles, and then it starts to do a third cycle, and this will become done, and then this becomes true, and then this will reset this one back to 0. So then um, that's how that works. It's a little tricky just because the 0 instead of starting with 1, but that's how it is in Allen Bradley. Everything starts with 0. So next we have our actual lighting controls, right? So for our left red light, what happens is the counter, right? Right here. So if our counter is greater than or equal to 11, then what we're doing is that's that 1 second, right? And I did the same thing down here. So basically, this is our 1 second where both of them are red. And then the other thing that makes the lights red is the side counter that we just talked about. So this will hold it in for the 11 seconds, and then this will hold it in for that final 12th second. So that's how those happen for both the left and the right. So next we have our green. So this is less than or equal to. So again, remember we start with 0. So this is actually 8, even 8 seconds in America and the way we think, even though it says 7, a 7 count. So so when it's less than or equal to 7, which would be the first 8 seconds, we want and our side is 0, the left side will be green. Like now, our count side is 1, so the right side is green. And now we're down at amber. So it's kind of the same thing. We use here I used a limit, which is the same thing as using a less than and an equal to. So basically what you're saying here is anything less than 8, meaning 7. So anything less than 8, we ignore, okay? And then anything over 10, meaning 11 and 12, we ignore. So that means we're going to look at 8, 9, and 10 as being our 3 seconds of being amber. And so when our counter, our second counter, is in between these limits, what we're going to do is then look at, are we on the left side or are we on the right side? And then we're going to fire our light. So next we have our crosswalk control. So here I use latches because of the delay with the red light. If you didn't need to do the security thing, like if you didn't care about your pedestrians getting ran over by crazy drivers and not giving them enough time, you could just use a seal-in bit here. And you could, as soon as they hit it and it was red, you could just go ahead and let them start crossing. But, you know, we care somewhat about our pedestrians. And so we're going to give them the best chance we can by doing a latch. And what we did is we took a bit here and we just said, hey, when this button is pushed, just hold on to that signal. Same with the right, hold on to that signal. And then over here, what we did is this is our counter. So when this is 0, right, meaning the very beginning of a cycle, that means that these are red. So then what we do, or I'm sorry, it doesn't mean that they're red, but it means that we're done and that we're about to have the beginning of this is the beginning of a new cycle. So then we come over here and we look, okay, is it the left bit or the right bit? Excuse me. So then we from up here, and then we look and we see, okay, well, which side is red at the moment, right? So we want to make sure that the side that is being active, turning green and yellow and stuff, that we're not sending pedestrians on that side. Okay, so that's why in this case we have a 1 here for the left side instead of our normal 0 like we do up here. Okay, because this indicates which side is going to be green and yellow. We want to focus on what side is going to be red, so we flop them. Okay, and then we latch in another bit, and what we do with that bit is we come down here to the actual light control of the crosswalk. So the first thing we have here is if it's less than or equal to 7, so the first 8 seconds when this is green, we want it to be solid, right? And so we'll just focus on that now. And so then we come over here and then we say, okay, well, is it what bit are we looking for? Is it this one or is it this one? And just as a secondary safety interlock, I went with, is this side red? Just as a secondary interlock, just for safety. And then, is this side red? And if so, let's go ahead and fire that light solid. Then what happens is once we hit 8, this becomes no longer true or happy or satisfied. And so this would shut off. So what we do down here is, again, we have another limiter. So between counts 8, 9, 10, and 11, we want it to flash. Now, this is the S47 bit. This is an internal clock bit. It's a 1 second on, 1 second off bit. It's used for the internal clock, and you can use it just in this, just like this. This is great when you have bigger, really big programs and scan times become an issue. This, if you need a 1 second on, 1 second off flash, this is perfect. If anything other than that, then you have to build your own flasher. But so that's what this is doing. So and so when this is flashing on and we're in this range, we'll flash. So that is what's going on there. And then next thing we have is when our cycle hits 11 seconds, right? We want to clear everything out. We want to just wipe out whatever side has already just happened. We want to not wipe it out, but we want to unlatch it. We want to let everything go so that it can move on, right? So once this is done with the crosswalk, we're gonna let that go so that it's not always telling people to walk and wasting that energy. All right. So thanks for watching.